So, imagine you are standing in this massive stadium, right? Surrounded by hundreds of giant screens showing the live action.
Yeah, and if even one of those screens lags by just like a fraction of a second, the whole illusion just breaks.
Exactly. It completely ruins the experience. So today, for you, we are going on a deep dive into the invisible infrastructure that makes that kind of absolute perfection possible. We are unpacking a highly technical spec sheet from HDTV Supply.
Right, specifically for the ZeeVee Z4KF2XSD ZyPer4K-XSE fiber decoder. It is quite a mouthful.
It really is. But, I mean, if your standard home streaming setup is like a garden hose, this box is basically the industrial valve controlling a Hoover Dam of video data.
And, you know, that Hoover Dam analogy really isn't an exaggeration because we're talking about IP streaming over a 10 gigabit fiber network here.
10 gigabits. Wow.
Yeah, it's an enormous pipeline, and it's built specifically to handle uncompressed 4K video.
Okay, but wait, what does uncompressed actually mean here? Because the spec sheet highlights 4KP 66 4.4.4 resolution. To anyone outside of video engineering, that just looks like a math equation.
I know, it does. So normally, video compresses color data just to save bandwidth, right? It groups pixels together and kind of guesses the colors.
Oh, to save space on the network.
Exactly. But that 4.4.4 means it isn't doing that at all. It's sending 100% of the color data for every single pixel, totally untouched, at 60 frames per second.
So it's just a completely pristine image.
Yeah, untouched, yes.
Which brings up the most, I think, mind-bending claim on this sheet, which is 0 frame latency. Honestly, that sounds physically impossible, like literal teleportation or something.
Yeah, it really does sound like magic, yeah.
Right. I mean, if I get a few frames of lag on a video call, it's just a minor annoyance. Why is absolute 0 latency actually necessary?
Well, think about the professional environments relying on this hardware, like a high-stakes military command center or a live global broadcast or, you know, that stadium you mentioned earlier. If you have a massive array of screens showing the exact same live event and they are even one single frame out of sync with each other, it's incredibly jarring to the human eye.
You'd notice it immediately.
Exactly. So absolute 0 latency ensures that every single pixel arrives exactly when it's supposed to, everywhere, all at once.
Okay, but if we are pumping an uncompressed, full-color 4K signal, that heavy, standard copper wire would practically melt, right? Or at least you'd lose the signal after a couple of rooms. How is it physically moving?
That is where the fiber optics come in. So this decoder supports 300 meters on multi-mode fiber, which uses multiple light rays for those shorter distances.
Okay, 300 meters makes sense for a building.
Right. But the real powerhouse here is single-mode fiber. That can push this same signal up to 10 kilometers.
Wait, seriously, 10 kilometers? You could send a flawless 4K signal across an entire city with that.
You really could. Unlike copper cables that lose signal over a short distance because of electrical resistance, single-mode fiber shoots a single, tightly focused beam of laser light over a glass core.
Wow, so no resistance.
Exactly. So it travels miles without degrading. And at the end of that 10-kilometer run, this one single box can manage a video wall up to 15 by 15 screens.
Wait, 15 by 15, that's what, 225 screens acting as one giant canvas?
Yeah, 225 screens. Or it can use its multi-view capability to display up to 19 different video sources on one screen simultaneously.
Okay, but hold on. Sending a raw, uncompressed signal 10 kilometers means it is literally leaving the building. It's crossing under streets, maybe passing through public infrastructure.
Yeah, it's out in the real world.
That feels like a massive vulnerability. How do you protect a citywide raw 4K stream from being intercepted?
Well, that physical distance requires serious lockdown. So ZeeVee built in AES 128 encryption.
So it's essentially scrambling this incredibly dense 4K puzzle into like a billion digital pieces, sending it miles across the city and having this decoder instantly reassemble it.
Perfectly, yes, without missing a beat. And it also layers on HTTP 2.3, which is a strict copy protection handshake.
So what happens if someone tries to tap into it?
If an unauthorized device tries to intercept the video, the signal just goes black, period. Add in 802.1x compatibility, which acts kind of like a digital bouncer, verifying every device on the network, and your data is locked down tight.
I mean, that level of processing, encrypting, transmitting miles over glass, and instantly decoding to 200+ screens without a single frame of delay, that really explains the price tag.
It definitely does. I mean, this is a serious infrastructure investment. The manufacturer's suggested retail price is $1,825.
Though, looking at the HDTV supply sheet, it's currently listed at $4,460.
Right, which is quite a deal for what it actually does.
Totally. So when you look past all the dense acronyms, this single, unassuming box acts as the critical bridge, delivering flawless, secure, and instantaneous video on a massive scale.
It fundamentally changes what architect of digital and physical spaces can actually build.
Which leaves you, our listener, with this final thought to ponder today. As hardware like this enables flawless, zero-latency visual data to travel across entire cities, what happens to our physical spaces when perfect, instant visual communication becomes the absolute standard everywhere we go?